Good day, Zanians! For this week's video, we will be talking about parabolas. We have two objectives for this week's lesson. These are, first, given an equation of a parabola, we are going to identify and solve for its important parts, which are the vertex, focus, axis of symmetry, directrix, focal diameter, and focal length. And secondly, given an equation of a parabola, we are going to sketch a parabola.
For number 1 example, we are given here an equation of a parabola, which is x minus 1 quantity squared is equal to negative 2y plus 6. So notice that our parabola here, or our equation here, is not in simplified form. So we will transform this equation into its vertex form. So we have here x minus 1 quantity squared is equal to, so we have here negative 2y plus 6. We will transform this into 4p times y minus k. So how are we going to do that? So negative 2y plus 6 will now become negative 2 times. We are going to factor out negative 2 from negative 2y and positive 6. So negative 2y divided by negative 2 is equal to y. Positive 6 divided by negative 2 is equal to negative 3. So now we have this equivalent equation of our parabola. We notice that the x here is the squared variable. Therefore, this suggests that our parabola has a vertical axis. Secondly, for the focal diameter, this is solved by the equation absolute value of 4p. And here in our equation, 4p is equivalent to negative 2. Therefore, we have here the focal diameter is equal to the absolute value of negative 2. And thus, the absolute value of negative 2 is positive 2. Now for the focal length, this is solved by the equation absolute value of p. And what is the value of p? Remember that 4p is equal to negative 2. So to solve for p, we will divide both sides by 4. And so here we have p is equal to negative 1/2. Therefore, the focal length is equal to the absolute value of negative 1/2, which is equal to positive 1/2. Now lastly, let's have the direction of our parabola. So when we say our parabola has a vertical axis, the parabola may open upward or may open downward. So for the direction, to identify if it opens upward or downward, we will be looking into our p. And since p here is a negative number, which is negative 1/2, which means it is lesser than 0, therefore our parabola opens downward. So now we are done identifying that our parabola has a vertical axis. Its focal diameter is equal to 2, focal length is equal to 1/2, its p is equal to negative 1/2, and so since p is equal to a negative number, then our parabola opens downward. So now we are going to solve for its vertex. So vertex has the coordinates hk, and hk can be solved from our equation of our parabola itself. So x minus 1 is equal to x minus h. And so therefore, to solve for h, we will equate x minus 1 to 0. So x is equal to 1. Therefore, the value of h is 1. For k, we have y minus k, which is y minus 3. So therefore, k, solving for k, we have y minus 3 is equal to 0. Thus, y is equal to 3. And so k has the value of 3. Therefore, hk here is 1, 3. For the focus, we have h, k plus p. So why do we have k plus p here? Why not h plus p? It's because our parabola has a vertical axis. So try to imagine our parabola has this axis and it can be here or it can be here. So therefore, we have a specific value of x here with an adjustments in the values of our y. So therefore, we cannot add or subtract p from our h to get the focus and the directrix, but we have to add p into our k to get the focus and subtract p into our k to get the directrix. And so therefore, we have here, for the h, we have 1, and for k, we have 3, plus the value of our p a while ago, which is negative 1/2. So therefore, we will have here 1 for our h, and k plus p, or 3 plus negative 1/2, is equal to 5/2, or that is 2.5 in decimal. Now let's have the directrix. So for the directrix, that would be y is equal to k minus p. And thus, we have y is equal to k, which is 3, minus p, which is negative 1/2. So this would be 3 minus negative 1/2. That would be 3 plus 1/2. So that is 7/2, or that is 3.5 in decimal. So now, lastly, is the axis of symmetry. So the axis of symmetry is our h. For a parabola with a vertical axis, that would be h. So x is equal to h, or x is equal to positive 1. Therefore, this parabola, which has the equation x minus 1 quantity squared is equal to negative 2y plus 6, or which has the equivalent equation x minus 1 quantity squared is equal to negative 2 times y minus 3, has a vertical axis. Its focal diameter is 2, focal length is positive 1/2, p is negative 1/2, and it opens downwards since p is negative. Its vertex is 1, 3, focus is 1, 5/2, directrix is y is equal to 7/2, and the axis of symmetry is x is equal to 1. So now we will be graphing our parabola, which has the equation x minus 1 quantity squared is equal to negative 2 times y minus 3. A while ago, we have identified that it has a vertical axis and it opens downwards since our p is negative 1/2. And our focal length is equal to 2. Our vertex has the coordinates 1, 3. Focus coordinates 1, 2.5. Directrix, its equation is y is equal to 3.5. And axis of symmetry, which has the equation x is equal to 1. So now let's proceed in graphing our parabola. So in graphing, you have to identify first if ano yung mga quadrant na madadaanan nitong mga points na nandito. So, we have to look into our vertex. Anong quadrant ba siya na belong? So, vertex, which has the coordinates 1, 3, both x and y are positive, belongs to quadrant 1. And so, therefore, we will be focusing more on quadrant 1. And since our graph opens downward, then therefore, we should also give space for quadrant 4. So, let's now create a Cartesian plane. Okay, so if napansin nyo, yung Cartesian plane natin focuses on quadrants 1 and 4. So a little space lang yung inilaan ko for quadrants 2 and 3. It's because dito na naman talaga na quadrant, iikot yung mundo ng graph natin. So therefore, wag na tayong mag-aksaya pa dito ng space sa quadrants 2 and 3. So that we can maximize the space for our parabola. And also, notice that our parabola or the points in our parabola are just small numbers or just small points. And therefore, we can divide these axes here into bigger portions. So now let's go with dividing our x-axis and y-axis. So, vertex has the coordinates 1, 3. So, 1 for x and 3 for our y. So, this is now the vertex of our parabola. Now, for the focus, the coordinates are 1, 2.5. So, 1 for x and 2.5 for the y. So, it's in the middle of 2 and 3. So, it's somewhere here. That is now our focus. Now, for the directrix, we have y is equal to 3.5. So, if we have 4 here, 3.5 is in here. So, therefore, since this is a line, so this directrix has the equation y is equal to 3.5. Okay, so next, we will have the focal diameter, which is equal to 2. So, ang focal diameter natin will be divided into 2. So, 1 to the right and 1 unit to the left. So, this is now the focal diameter of our parabola. It has 2 units. So, 1, 2. And it goes through the focus. So, this is our vertex again, and this is our focus. So, the graph of our parabola is expected to touch these particular points. So, therefore, graphing now our parabola, we have to touch these points here. And of course, we have to extend our parabola going downward. Okay. And of course, our axis of symmetry. So, axis of symmetry, it has the equation x is equal to 1. So, it's here. X is equal to 1. So, this is now our axis of symmetry, which has the equation x is equal to 1. So, now, this line here is our focal diameter. Which is equal to 2. This line here, the distance between the vertex and the focus, or the vertex and the directrix, is called the focal length, which is equal to positive 1/2.
Able to identify and solve for the important parts of our parabola and sketch a parabola. This is your teacher, Miss Mary Christine Gamuzo Antalan, saying thank you and keep safe, Damians!